If you observe any article made up of iron, it may be a silencer of your bike, or it may be a railing of your gallery, or any article, such article which is made up of iron. If you keep such type of things for long exposure to the atmosphere, what you will see that there is a change in a physical appearance of such type of things. Whenever I say a physical appearance, it may be a change in a color, right? Or it may be a change in a texture of the surface. So this type of things happening, so we call that to be a corrosion. Some people call that to be a oxidation. There are other processes like burning of the fuels, right, during transportation, or it may be a working of the battery. All these things have a great relation with the topic redox reaction. So my name is Indresh Naik. I am going to take you ahead with the concept of the redox reaction. First, I will break this word. What does redox mean? Redox is very simple. RED of the redox stands for a reduction, and OX stands for the oxidation. So here in this topic, we are going to learn about the reactions in which a reduction and the oxidation takes place simultaneously. So there are two definitions for the reduction and oxidation. Before I take you ahead with this chapter, I'll explain you what is the meaning of reduction and what is the meaning of oxidation. So there are two definitions of the reduction and the oxidation. The one is known as a classical concept and other is a electronic concept. So with respect to the classical concept, I'll write this. So classical concept of reduction and oxidation. Electronic concept I'll explain later. First we'll understand this. So by definition, so I'll explain first oxidation. By definition, oxidation is addition of oxygen, or it is addition of electronegative element. Okay, so one is addition of oxygen, or you need to add the electronegative element. Okay, that process is called as oxidation, or removal of hydrogen, or I will write this slash, or removal of electropositive element, so addition of oxygen or the addition of electronegative element, removal of hydrogen or removal of the electropositive element. This is stands for the classical concept of the word oxidation. Means, for example, if there is a group 2 element, magnesium, if it is reacting with a magnesium oxide, the compound what you are going to get is MgO. Okay, I'll balance this. What has happened? There is a, what I'll say is that it is a oxidation. This reaction represents a oxidation of Mg. Why? According to this concept, a magnesium is added to the oxygen and you are getting a magnesium oxide. So this is the oxidation of the magnesium, that is Mg. One more example I'll take. Sulfur and the O2. Sulfur reacts with O2 to form a sulfur dioxide. This is what? This is a oxidation. This is an oxidation of sulfur, right? So this is the a basic definition of the oxidation. We'll take a mixed definition, that is a removal of the hydrogen and addition of the oxygen. There may be a process where both the things are happening, that is addition of the oxygen and removal of the hydrogen, right? For example, if there is a methane, if I burn this in the presence of oxygen, what do we get is carbon dioxide and the water. Take this. Yeah. So I'll put this over here too. This is balance chemical reaction for this, right? So here you can see that in whole process the carbon was with hydrogen, right? It was a methane, it has changed to carbon dioxide. In this process there is what? There is a removal of hydrogen. Yes, this is also a oxidation, and also you can see that hydrogen is replaced with oxygen, and there is a addition of oxygen. So there is a oxidation of, what we can say is that oxidation of carbon in this whole process. So this is a classical concept we can think of. And next definition is about the electronegative element. Whenever we talk about the electronegative element, which are the most electronegative elements of the periodic table? These are the halides like fluorine, chlorine, bromine, iodine. Let's add such type of, let's try to react a magnesium, and this is fluorine. Fluorine will always exist as F2, right? Diatomic molecule, and you get is MgF2. This is also a addition of the electronegative. This is an electronegative element, right? Electronegative element. This is the process where we are saying that there is a oxidation of Mg. After the reaction, F2 is added to the magnesium. So this is the oxidation process. Next is reduction. Reduction, according to the classical concept, it is addition of, let's take a, with respect to the, first I will write, it is removal of oxygen. If you remove oxygen from one particular molecule, we will call that to be also what we call a reduction. Removal of oxygen or electronegative element. If you remove oxygen or electronegative element from that particular compound, we will call that to be a reduction of one of the element from that compound. Okay, and next is other definition I can say of the reduction is addition of hydrogen or electropositive element. Okay, very good definition. Good example we can take is a mercury oxide. If you heat this to certain temperature, there will be a mercury and the oxygen which will be forming, right? So what has happened? There was oxygen with mercury. In the product, there is no oxygen with the mercury. The oxygen from the mercury is removed. So what we can say is that this process is a reduction of mercury. Addition of hydrogen. Like many unsaturated hydrocarbon you take and you do add them a hydrogen, we will call that to be a reduction process. So if we take a hydrocarbon like this, if it is H2, what you are going to get is right, hydrogen is added to one hydrogen to this carbon, another hydrogen to this carbon. So this is a reduction. What I can say is that it is a reduction of whole compound, reduction of whole compound, reduction of ethene, I will say. This is ethene because hydrogen is added to the whole molecule. Next is electronic concept of the oxidation and reduction. Electronic concept of oxidation and reduction. So, according to the electronic concept, it is said that oxidation, right from here, it is loss of electron. This is so simple definition, you know. And reduction is it is gain of electron. Now the question arises, why elements or atom do lose their electron, or why do they gain electrons? The reason is simple, you know. If any chemical reaction is happening, means it is a breaking of the bonds. Breaking of the bonds means what? Bond means it is an electron, a pair of electron. It is a transfer of the electron or sharing of the electron. Why do all these things happen? What is the main aim of all these elements? All the elements or the atoms which doesn't have a stable, like whose octet is not complete, who doesn't have 8 electrons in the outermost shell except elements like helium, they always tend to lose or gain electrons to complete their octet or to have a stable noble gas configuration. If I say that there is a, let's understand this concept with that, like sodium is there. If sodium is there, like this is an atom, what is the charge on the atom, right? Charge on the atom, whenever I say atom is electrically neutral, right? Charge is 0 because there are equal number of the protons and the electrons in the atom, right? This is a sodium atom who is electrically neutral. Everyone should know this. Electrically neutral. Atom is always electrically neutral. Now, if we check the electronic configuration of the sodium, it is this way, right? Electronic configuration of the sodium is 1s2, 2s2, 2p6, 3s1. Means if it loses its one electron, then it will attain a noble gas configuration to that of the neon, right? So what happens is that it can lose its electron to form a Na plus ion plus that one electron I am writing separately. So this is a ion, because I am calling this to be ion because it is having a charge, isn't it? So here what has happened, which was sodium was in 0, it was having a 0 charge. There is an increase in the charge to +1. Why there is an increase in a charge? It's very simple. Like earlier here there was a 10, sorry, there were 11 electron and the 11 protons. This is minus 11 units and this is protons means positively charged, that is plus 11 units, that was is equal to 0. Here it is having a +1 of charge, means over here if we count, then it has lost the electron and the number of protons are same. So I will say that plus 11 positive charges, and now here it has lost 1 electron, means instead of 11 it is having a 10 electron. So I am writing minus 10. So plus 10 and minus, plus 11 and minus 10, it is plus 1 of charge. So that's why I will say that here sodium has lost the electron, so it is a oxidation of sodium atom. A sodium has oxidized. You can remember it this way. It was 0. It has changed to plus 1. This is oxidation. Increase means oxidation. You can also remember it this way. Increase in charge is oxidation. Let's come to the reduction. What is reduction? Reduction is gain of electron. Like if you see the halides, like group 17 element, they are always in need of one electron. If you just take one example like a chlorine, if I take a chlorine, fluorine, then what is the electronic configuration? Let's take fluorine. Its electronic configuration is 1s2, 2s2, 2p5. This is fluorine's electronic configuration. And if it accepts one electron, then it will have a noble gas configuration. There will be a 6 electron, that is in the outermost shell. There will be a 8 electrons. Let's understand the, like chlorine for that matter will exist as Cl2, right? When this will accept 2 electron, because chlorine existing is it will exist as Cl2. Sodium exists as Na plus, right? So same way Cl2 will exist as Cl2. It will require a 2 electron. This will change to Cl, 2Cl minus. What does this mean? You know, like how many electrons does a 1 chlorine accept? Over here, the thing is 1 chlorine accepts 1 electron. How? If I want to write this to be Cl and Cl, I will write this to be in the splitted form. Instead of 2, I am writing Cl minus and Cl minus. And this molecule I am writing as a Cl and Cl. Here it is 0, 0. Since it is a molecule, it is in the 0. So for this molecule, for this part of the molecule, for converting from 0 to minus 1, there is addition of 1 electron, I will say. And from here to here, it is addition of 1 electron. That's why I am writing this to be is equal to Cl2 plus 2 electron changing to 2Cl minus. It is this way. Now why Cl is having a minus charge? If we look it into the atomic form, if I divide this, if I write it in the atomic form, let's say this is a chlorine atom. Let's say this is a chlorine atom, 1 chlorine atom. Let us understand this with respect to the 1 chlorine atom. Chlorine is having how many electrons? Okay, I think I made a mistake. Not a mistake. I wrote over here fluorine and I showed you the chlorine. Still not an issue. You can write this electronic configuration for chlorine also. And it is what? 1s2, 2s2, 2p6, 3s2, 3p5. And if this accepts 1 electron, it will attain a noble gas configuration to that of the argon. Okay, so let's say this is a chlorine which is having a 17 electron plus 17 protons. Just check if it is coming into the frame. Yes, it is coming into the frame. So 17 electrons and the 17 proton, that's why it is minus 17 plus 17. So this is equal to 0. So this chlorine is in 0 oxidation state. For this 1 electron I am adding and it will change to Cl minus. Chlorine doesn't exist in atomic form, it exists in this way. Just to understand with respect to 1. Here there will be in this form, how many atoms will be there? Sorry, how many electrons? There will be a 18 electrons plus 17 protons, means minus 18 plus 17, which is equal to minus 1. So it is having the minus 1 charge. So it was 0, like this was also 0, it is changing to -1. From 0 to -1, it is less, decrease. So it is a reduction of the chlorine. So this is a basic concept of understanding what is oxidation and reduction in terms of the electron. This is a small definition, that is oxidation is loss of electron and reduction is gain of electron. Let's understand a redox reaction by the reaction of the sodium with the chlorine. Like sodium is existing, then sodium will exist as a Na, and chlorine is existing, then chlorine will exist as Cl2, right? It will not exist in an atomic form. So what you get is 2 moles of NaCl. This is what you are getting. Now here if you see in this process, what is happening is that sodium is having a +1 of charge and chlorine is having a -1 of charge. So here one sodium, with respect to one sodium, what I can say is that sodium is in +1, there is a loss of 1 electron. E minus means electron. And here Cl is in 0, it is changing to -1, Cl2 is in 0, like 1 Cl will be in 0 oxidation state, and it is changing to 1 Cl is changing to -1. So that's why I am writing there is a gain of 1 electron. So in this process, in this whole process, I can say that a sodium is oxidizing, right? Or oxidation is happening at the sodium, right? And chlorine is getting reduced or reducing, or I can say that oxidized and reduced. Sodium is oxidized and this is reduced, so reduction. Now why the sodium loses its electron? The thing is that sodium simply won't lose its electron. There should be someone to accept the electron, right? So since chlorine is there to accept the electron, sodium is losing. Simply if you keep a sodium in the inert atmosphere not reacting with another, sodium will not lose its electron. Since there is a chlorine who can accept the electron, that's why sodium is losing. So what shall I say for this? Because of chlorine, sodium is losing its electron. So chlorine is what? Chlorine is what? Chlorine is oxidizing agent. Because of chlorine, the oxidation of the sodium is happening. Oxidizing, chlorine is oxidizing agent. Now oxidizing agent itself gets reduced. Remember this, oxidizing agent itself gets reduced. And what about sodium? Chlorine is going to from 0 to -1, right? Chlorine is accepting 1 electron. From where the chlorine will accept if no one is there to donate, right? So chlorine is, since sodium is oxidizing agent, I will say that chlorine is reducing agent, sodium is reducing agent. Sodium is reducing agent, means itself gets oxidized. So there is something called as oxidizing agent and the reducing agent. Oxidizing agent will itself get reduced and the reducing agent will itself get oxidized. So here the reduction and the oxidation taking place simultaneously, that's why we will call this to be a redox reaction.